Well, hey guys, I have another Class D amplifier board to review here. See if I can get a close-up focus. TDA7492 board, digital audio amplifier board, 2x50 watts. And we will take a look at it and see if it really is that value or not. Though I would debate the use of the word digital. It's a pulse width modulated type amplifier. That's what Class D means. Nothing really to do with storing of the values, voltage level values in the amplifier, so I don't know why they would call it digital. But anyhow, let's take a quick peek at it here. It comes with a cord, looks like an input connector cord. And here is the board itself. I do not notice any labeling. How do you know what's what? I see this line here. Looks like it runs to this capacitor. So this has got to be power. These are likely the outputs just because of their position. It is a stereo bridge type amplifier. So there will be 4 coils on the output. It's actually an LC filter that filters the high frequency pulses out. Just gives you the audio signal. One thing it does have is a decent sized heatsink. If you watch my videos in the past where I've reviewed a lot of these little boards, many of them do not have any sort of heatsink. Even though it's Class D, it still has to get rid of some heat because it's not 100% efficient. And this being a little more power than the other boards, certainly does have a decent sized heatsink. Okay, so let's give a listening test, power test, and I'll do other measurements and all that good stuff and see how this thing performs. Hooked it up to my speakers, power supply, and music source, and gave it a listen. Of course, I cannot project the quality of the music through the cheap $40 camera microphone here, but to my ears it sounds very good. I tried different power supply voltage levels, played the music loud, played music soft. I couldn't find anything that would cause issue with the sound quality, so it seems to be good as far as that goes. And before I forget, I should mention that I paid $13.50 at Parts Express for this thing. They have it on sale, normally $16.50. You can probably find it for less online, I don't know. They usually sell these things on Amazon and stuff like that. While I was at it, I took some other measurements. First off, I wanted to see how low the voltage, power supply voltage would go before it would cut out, and it ran down to 7.5 volts. So if you wanted, you could run this thing at 9 volts. Of course, you would get a lower output power, 2 or 3 watts maybe, but it will run on lower voltages. So you can use it with 12 volts, for example. The quiescent current draw, that means as it sits here not playing any music, it draws some current. At 24 volts, I was getting 100 milliamps, and that's pretty good. The little coils will absorb some of the energy and get warm. At 12 volts, it drew 40 milliamps. That's great for battery power. Plus the lower current it needs because it's more efficient than a standard amplifier. You know, a linear amplifier, a Class D, will require less operating current, so great for batteries. One thing I did notice, it had a light hiss. When it's not playing music and you put your ear close to the speaker, you do hear a hiss. I don't think it's loud enough to be an issue. Maybe if you have very high efficient speakers. But just note that there is some hiss to the amplifier. And it has good gain for music players. That's one thing I run into with line level type inputs. Music players, their level is a bit lower in output than standard line level, and even though you turn your music player all the way up, you don't drive the amplifier to its maximum capability. But this one seems to have enough gain, so that's a big plus if you want to use it with a headphone type music player. So what's the supply voltage range of this thing? Well, it's rated up to 30 volts, but when driving 8-ohm loads, you want to have it up to 25 volts max. With 4-ohm loads, due to the extra thermal dissipation and maybe current limits you run into, you can go up as high as 20 volts. So I would just say 24 volts with 8-ohm loads and 18 volts with 4-ohm loads, and you're golden. And what I'll do next is power this thing up and see what kind of output I can get in terms of wattage. Now, because this thing cannot put out enough current, I'll switch over to this. I'll measure with 4-ohm loads. This will put out about 14.5 volts. Okay, I have the 4-ohm non-inductive loads connected to both channels. Of course, both channels driven in these tests because it is a stereo amplifier. And here's what we get. Very nice narrow sine wave. Usually with these Class Ds, because of inadequate filtering, this waveform will have a thickness to it because it's not removing all of the switching signal. So there's some residual coming through and you're getting kind of a thickness to the line. But this is a nice clean sine wave. Now as I turn it up, you start to see a little bit of fuzziness. It seems that, I don't know what's going on, maybe the cores start to saturate of the coils and some more switching noise gets through. But there's clipping. And I'm getting about 7.37 volts just before clipping. Okay, with my $1 cheapo scientific calculator, 7.37 volts squared divided by 4 ohms. Exactly what I would expect. About 13.5 watts of output power. With, well, this thing's putting out about 14.5 watts, or I'm sorry, volts. And that's exactly what I would figured, right in that range. So it's doing pretty good there. Now, if you operated it at, say around 18 volts with 4 ohm loads, you could do much better. You might get 20 watts, maybe 25 watts. Because it does have that headroom, it is a little more powerful. But what I'm going to do now is I have to rig up a power supply because I do not have a good clean 25 volt supply that I can test this thing and I will switch over to 8-ohm loads and see what this thing can do. So stand by, I'll rig something up and we'll go from there. Geez, what a mess. I have the dual 8-ohm loads connected to the outputs. I jury-rigged a power supply together using this 25.2 volt transformer, full wave bridge right there, and a filter cap to supply the amplifier. And because of the voltage will go way above 30 volts on the DC side, I use my variac. Right now it's 22 volts. As I turn the amplifier on, you see it drops it down. So I'll have to take the test while it's under load and tune that up to about 24 volts and see if I can get a measurement. This is a good argument why I really need to get a good regulated supply. Just they're expensive and I don't have the money right now for that. So, got to do it this way. Okay, it's actually at 22.8 volts. And that's the best I can home it in. And that's right before clipping. We're getting 13.7 volts. And let's punch that in the old calculator. Square that, divided by 8. Oh yeah, about 23.5 watts of output per channel. Now if I went full 24 volts on the supply, probably get it to 26 watts maybe. So in summary, it's a pretty good little amplifier. In fact, it's the best one I've tested so far. The only thing is they didn't give you any instructions, at least none came with mine, so I did have to label that, and you have to make sure you have the correct phasing on those output connections. But it gives you a decent amount of clean power. Sounds good. It actually includes a heat sink this time. You can use it at various supply voltages, which is pretty common for most of them, but I mean you can run it from 25 down to 9 volts. Like I say, with lower voltages you'll get less output power, but it makes it very versatile. So yeah, this is a very good little Class D chip amp. I would recommend it. The only thing that I can't measure is its longevity. Now if it has kind of crappy Chinese components on it, I don't know how long it will last. But other than that, I would recommend this. Well, that's it. Thanks for watching.